we'll just cover this first. Okay, so let's start with few terms which is there on the screen, right? Only these you need to know. So what is an attack surface? So attack surface is basically something from where you enter. Okay? Maybe uh, this entire topic which we are studying now, these prerequisites in defense in depth, we will take a generic example so that you understand in a better way. And that example would be something like this, okay, uh, of a castle. How the security was there in the medieval period in a typical European castle. So basically, if you talk about attack surface, it's basically the entry points from where you are getting inside. So there could be multiple gates. Okay, if you are trying to enter from here, or maybe there must be few back gates also. Different areas of entry are there. All of them sums up together to be the attack surface. So attack vector is how you enter. Okay, you have a road or you have a gate open, but you need to enter it somehow, right? You need to enter it somehow that nobody stops you or you get in without any issues. So that is the thing which we say as attack vector. So maybe you are masquerading as someone who stays inside, or maybe you are masquerading as someone who is to sell things. Okay, so for example, some merchants are being allowed to come inside the castle without any identification and all. Okay, you have your goods and all loaded on your back, and they just open the gate and allow you through. So this is a legit entry point, right? This is a legit entry point. You cannot stop that person because he is there to sell. If you start stopping everyone, then they will get into trouble, right? Like it would be a chaos at the gate. So attack vector is like how you enter. So these are the two things. Okay, now let's implement this in a normal scenario. Okay, our, our application scenario basically. So you can see a diagram, right? No, you can see my screen.
Yes, we are able to see. Yes, I
Yeah.
can see.
Okay. Okay. So this is the typical architecture which we'll be working upon. Okay. So this is the architecture. First, I will explain you the flow, like what's happening.
The screen share, I think it has ended. We're not able to see the screen right now.
Is it visible now?
Yes, now it's visible.
Okay. Perfect. So this is the application, a microservice application which is hosted on Azure. There are four to one, two, three, four components running inside the cluster. One is your front end, and there are two backends, and there is one database. All these are running inside in your AKS cluster. There are other cloud resources as well, like key vaults and storage accounts and any other thing which is required to run the application. And this cluster is able to communicate with these cloud assets as well. So this is under the cloud subscription. So second thing is the flow. Okay, so this is the user who is browsing this application. He has the URL with him, and you it just visits that particular URL, and his browser is the client side of the front end where all the client codes are running, scripts are running, the Java scripts. So, for example, he issues any basic functionality of the application, then the API which is mapped to that particular functionality is then being called from front end. and the traffic goes in such a way that the URL for the backend, okay, from front end it's going to the API, correct? And in the front end, you have in the code itself, you have embedded a URL which is of this particular API. So the traffic goes in this way that it hits the gateway, front door gateway. From front door gateway, it goes to the API management service. From there, it goes to the load balancer. And from load balancer, it goes to the ingress and then it goes to the backend. So this is basically exposed to internet. This is exposed to internet. It's coming via the internet. The URL which is here, it's this particular guy's URL, the front door's URL, and the routing is configured in such a way that API is going in such a way that, for example, abcd.com slash xyz. So abcd.com is configured here on this interface. It's the IP, it's the URL of this gateway, and then it blindly forwards the traffic to API manager, and this API manager checks the absolute path. Okay, like it's basically slash XYZ. So slash XYZ should be forwarded to a particular address, which is that particular API which is exposed here. So this is the flow. This is the flow from front end. It's going to the internet, and from internet, it's coming to the back end. Now you would ask that definitely why it's taking the long route, right, from internet and then to the backend. So there are multiple ways where you can design. But for understanding purpose, I have created this architecture so that we clear our topic easily. Okay, and the traffic which goes out from the cluster is going via internet firewall. They have configured the routing of the cluster in such a way that any traffic goes through the internet firewall and then goes to the internet. So this is the basic flow which you would be following throughout our course. So if you have any questions, please let me
Uh, Ahmad, here after backend contacts the DB,
know.
from there the response goes out to the internet, right? Through
No,
firewall, internet
no,
firewall.
no. When the backend responds to the DB, yeah. So this part you are saying, okay. When the DB gets a request, it sends the response back to the backend only. Okay, it sends to the backend only, and from backend it goes again from where it originated. Okay, it will go to backend
Okay.
two, from backend two it will go to backend one, and
Mm-hmm.
yeah, and from backend one, when backend one knows, okay, I got this, and backend one is also connected via load balancer, so it simply forwards it to the load balancer. Okay, and in the same way,
Okay.
if you see in the same manner, the traffic return response comes back in the same flow from where it went. But there could be scenarios where you are updating your database. Okay, it's a Linux machine.
Huh.
Okay, or the base images of Linux on this particular container, and when you just issue a basic sudo apt update command, so it will communicate with the repository, right, where it will update all the packages which it holds. For that it needs internet access. So for that, when these guys are initiating a TCP request for a public URL, at that time this routing will come into picture. It should go via the internet firewall when they are generating. So this is the simplest use case which I told you for the upgrade one. There are other scenarios as well where the pods might need the internet communication. So why we are sending it via firewall? Here you can control and monitor the traffic. You would say, okay, this particular cluster needs access to these Linux URLs, Linux repositories, X, Y, Z. You have a list of 20, 30 URLs which you can whitelist here, and rest everything would be blocked. So that's why it
Okay.
goes via the internet
Yeah.
firewall.
Okay. And Mohammed, why do we use two backends, backend one and backend two?
That it's like just as it is. I've just designed it. There is no specific reason for that.
Okay.
But once
Is
I'll
it DR? Mhm.
it's they are two independent services doing different tasks. Okay, and
Oh, okay.
yeah, yeah, it's that way. So
Okay, okay, got it.
so if just ignore this, yeah. So if you see here now, what is the attack surface and vectors? Coming back to this point, okay? Attack surface and attack vector. You understood this point, this flow. Now you see the attack vectors, attack surface would be the areas in your
Front
application,
end.
yeah, which is exposed to internet and anyone can get into. You are at it, just take it as a gate. Okay, you are opening a gate for everyone. So this is the
Mhm.
entry point. This is the entry point, path one. You can say this as an attack surface. You can say this
Okay.
part 2 as another attack surface. Okay, part 3 as another attack surface. These are the cloud assets. So how have you configured your cloud
Mhm.
assets? Maybe you have configured it for public access. Okay, you can, anyone can directly access it. There is no restriction. Exposed to internet again.
Mhm.
So just to cut you out here, you guys are aware, right? That whenever you spin up cloud asset, specifically Azure, you can create private links, right? The concept of
Yeah.
private link, yeah, perfect. So someone has not configured it via private link and exposed it via internet. So again, this also opens up a path. So these are the attack vectors. Okay, now sorry, attack surface. And now when you talk about
Surface.
attack vectors would be how you are getting in. So maybe this has port 80443 open. So that is an attack vector. Maybe it has some
Mhm.
misconfiguration front end. That is an attack vector. Or maybe someone has left admin page open. Okay, there is no restriction, no password and all. That is an attack vector. So attack vector could be anything via which you are getting into. Okay, so there are two parts here.
Mhm.
One, you need to expose it. Okay, and exposure is not enough. We are talking uh, in with respect to an attacker, like how what he would be needing from us. So exposure is not enough, right? Exposure is not enough. You need some misconfiguration, some security loophole, which he will use as an attack vector. So attack vector is nothing but a security loophole. So you would say, okay, opening a port, how can it be a security loophole? Definitely, opening a port is not a security loophole, but opening it in an insecure way is a security loophole. When I say insecure way, maybe you don't have IP restriction, you don't have rate limiting, you don't have DDoS protection, you don't have a WAF protection. So if you design it in an insecure way, it becomes an attack vector. If you design in a secure way, it doesn't. So this is the thing. So any questions related to attack surface and attack vector?
No, so far. Okay.
It's
My side,
clear.
actually.
It's clear.
Okay, one point again I want to add. So maybe there are few websites which define attack surface and attack vector as the same thing. So maybe what they say is attack vector is a gate and attack surface is the list of gates, all the gates together. So it's one and the same. It's singular, and the above one is plural. But don't get yourself confused with that because that's not the case. Okay. So again, I'd be asking any questions with these two things. You please feel free to ask before we move forward.
No questions so far. Okay.
Yeah. No, nothing. It's clear.
Okay. So now we'll move to another part, which is the vulnerability, and we will take vulnerability, threat actor, threat. All these three things together we'll take. Okay. So what is a vulnerability? So you would say that SQL injection is a vulnerability, correct?
Uh,
I mean, not yes, yes, but not having enough protection against
Okay,
That
so I would say SQL injection is not a vulnerability. SQL injection is the threat. Okay, SQL injection
Yes.
is the threat. Vulnerability is something
Mm.
which can lead to SQL injection. So if you remember from yesterday's session, input validation is the weakness which results into SQL injection. Okay,
Yeah.
okay, okay, got it.
Got it.
so yeah, so keep these two concepts also very much clear. I know in terms of the industry and internet, we term this as CVEs, common vulnerability, and all these terms are there, right? But don't confuse yourselves with that. Uh, these are the two parts, okay? And if you see here, okay, I would say this is the database, and this database can be exposed to SQL injection vulnerability is a threat to it if these guys are not front end, back end, from wherever the request is passing through. You see, from here to here to here, everywhere till it reaches DB. If in along the path these pods or these containers, if they are not validating the input, then that is the weakness, that is the vulnerability which can lead to the exploit of SQL injection and compromise your database. Okay, clear till here?
Yes.
Yes, clear.
Okay, threat actor is very simple. It's the attacker, it's the hacker. Okay, so
Mm.
nothing. And exploit is the entire process where you exploit a threat. Okay, where you are able to do when you are able to do an SQL injection, that's the exploit. That's the exploit which you are doing. That you have done your attack. Okay, your attack is done, completed. That's the exploit. And now comes the concept of risk, which says impact into likelihood. This is a universal formula of risk. Impact into likelihood is the risk. Okay, so very simple thing. I will give you an example of. Okay, you are carrying your wallet. Okay, and you have lots of money. Okay, in your wallet. Okay, and the likelihood of falling is high because you don't have a proper pocket. Okay, it's loose, and you're traveling on a two-wheeler, so likelihood increases, right? Likelihood of the
Yeah.
what is the risk here? Like, risk is losing your wallet. Okay, and likelihood is very high. And what is the impact? Impact is that you will lose lot of money. So that makes,
Mm.
see, two high values when multiplied increases the risk, definitely correct, because this is the multiplication. But in on the same day, okay, you don't have any money in your wallet. Okay, it's empty, completely empty, no card, nothing. Likelihood is very high, but the impact is null, so the risk becomes null. Okay, and on the other hand, the impact is very high. Okay, you are carrying every possible important thing in your wallet. Okay, cards and all. But you have a proper, what do you say, a proper pocket with chain and all, so the likelihood of falling is null. It will never fall, or you cannot lose it that easily. And the impact is high, but the likelihood is low, so the risk becomes low. So you got this, right?
Yes.
Yes.
Yeah.
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 Okay. So everything in DevSecOps, every pipeline which you run, vulnerability which you found, and remediation which you work upon, works upon this formula. Okay. If you are able to identify the high risk vulnerabilities or high risk areas in your environment, then you are good to go. Okay. So now let's implement this thing here. So Mala, you were asking, right? Why two backends? So
Yeah.
yeah. So let's understand with some business logic here. So what happens is you have a API interface which is this one. Okay, backend one, which communicates with the front end. Okay, and it also performs some action. You can add another line here where it communicates with the database also. Okay,
Okay, both front end and database. Okay.
Yeah. Oh, just a second.
Huh.
So you can assume that it's communicating here. This guy is also communicating with the tools here, okay, with the
Hmm.
cloud assets, and it gives the
Hmm.
response. This is a particular API layer only. There are multiple APIs configured on this host, on this particular container. It's dealing with all the API requests and giving back the response. But there are
Hmm.
some functionalities, okay, which is out of scope for this. Okay, there is some critical tasks which is like to write some important information into the database, write it, okay, not extract it, just the way this backend one is doing. He's doing some critical operations here, so that's why you have configured it separately. Okay, so not to mix the code of these two, or maybe if any changes or any hotfix or any upgrade comes, then these two should be separate because their role is separate. So if I say I have an upgrade for backend 2 this weekend, then the entire flow is up. That which the all the functionalities of the application which are dependent on backend 1, all of them would be up. Only a list of functionalities would go down which are dependent on backend 2. So that's why I
Hmm.
have done a separation. There are two different backends.
Oh.
This is one of the reasons. There could be any reason. With this
So we are
completely,
separating the functionalities.
yes, separating the functionalities.
Hmm.
Okay, and now the thing is that you ran SAST tool, just the way we discussed yesterday, right? There that
Hmm.
somebody has pushed a code. Somebody has pushed a code into this one also. Okay, and both are
Hmm.
different developers. Somebody has pushed the code and release is somewhat 2 weeks, or you can say in the current sprint only the release is there, and it should be for both the guys. Okay, for both the backends you are deploying a new release. So, but when the developer pushes the code and raises a pull request, his pull request fails. Both of the backend developer 1 and developer 2. Both the pull request fails, and it comes out to be some code related vulnerabilities. For simplicity, let's take SQL input validation vulnerabilities. Okay, there are no input validation in place for both the backends, and the security engineer gets this. Okay, and this particular part which is to be worked upon is too lengthy now. Okay, because you need to as we discussed yesterday, right, we need to again work with the developer, make code changes, and then again redeploy, test and all everything, and you have limited
Yeah, we need
time.
to repeat the cycle. Huh.
Yes, you have limited time with you. Okay, you have limited time with you, and this is backend on backend 2. SQL injection vulnerability is there for both these guys. Okay, now what what is the risk for that vulnerability? Okay, risk. Okay, what is the risk? So risk is, let's take step by step. Impact. What is the impact for backend 1? Okay, well, impact of SQL injection, definitely. If you can pass SQL injection commands to backend 1, it will directly go to the database, and you can compromise the infrastructure from backend 1
Yeah.
also and backend 2 also. Correct? The risk is
Yes.
high for both. But when you come to likelihood, okay, when you come to likelihood, this particular backend is not exposed to internet. You cannot hit it directly from here. You cannot hit it directly from internet, but this one is exposed to internet. Okay, this one is
Hmm.
exposed to internet. Correct. And
Yes.
how the flow is any particular functionality which these backends hold. Okay, for example, he backend 1 holds 10 functionalities, he holds 4 functionalities, but the traffic
Hmm.
comes to backend 2 via backend 1 only. This is the middleware layer. You have to go
Yes.
through
Back
this
in.
to reach here. Okay, so this has to
Yeah.
be has to be exposed to internet. Okay, so for in this scenario, the backend one needs quick fix, because here the likelihood of an attacker reaching this particular backend is high, because it is exposed to internet. Okay, any way, from any xyz way it can come up, The attacker can get in. It's a path, okay? It's a path. It's a gate which is open, and the likelihood is at least something. Maybe you have a lot of defenses in place, but the likelihood is at least there, right? You cannot ignore that. On the other
Yeah.
hand, when you come to the likelihood of this particular backend too, it's not exposed to internet. You cannot reach it anyhow. You have to sit inside here. You need to take access of any one of the pod, then only you can communicate with this backend too. So the
Hmm.
likelihood decreases, right? The likelihood falls drastically. That it's like that you need to find that particular four functionalities, four API endpoints. First, you need to find that URL to hit this backend too. So from here, if the attacker knows, okay, I am entering abcd.com slash xyz14. So xyz14 is the functionality of this backend. So this will be forwarded to this backend immediately. But he needs to know these things, right? He needs to. How will you know if somebody is attacking you? He cannot know these many informations of your application,
Yeah.
right? It's very difficult. It's not impossible, I repeat, but it's difficult. So the likelihood
Hmm.
decrease. But this is exposed. Yeah, please go ahead.
I have a small doubt here. When there is a there is a threat on backend one, since it's a middle layer and backend two is also connected, then backend two also will get affected, right?
Yes, backend 2 will also get affected. Your your question is completely valid. But
Huh.
see, if now let's imagine it in a way of attack. Okay, same thing in a
Huh.
way of attack. Attacker has a tool. Okay, he has the URL of this backend one. Anyhow, he got that URL. Okay, and he
Hmm.
has that URL with him, and he passes a malicious payload to this backend. Okay,
Hmm.
this red thing is the traffic. Okay, this is
Okay.
what this
Okay.
is what this is the malicious payload with
Hmm.
the SQL queries. Okay, with the SQL queries command it's coming up here. He's directly passing it. Okay, he's directly communicating with this backend. He's not coming via the front end. He's directly going to the backend, and he has the path with him on which this backend listens. Exactly, the absolute URL with the paths. This backend is configured for input validation in the code. So this backend will reject this SQL packet here itself. So
Hmm.
it will never
Yeah.
reach here. It will never reach here because input
Okay. So.
validation is stopping it here
Hmm.
only.
Okay. Okay.
So you see the likelihood of an attacker getting to this backend is very low, very low.
Yes.
It needs to go through this. So that's why you will rush for this backend one rather than backend two. And definitely all of your applications, microservices should be patched. But here what we are talking about is the risk. We need to patch based on the risk. Like what is the risk
Okay.
for a particular microservice? So this is what risk is. So uh, don't worry if you like. We'll check in the security architecture review section. We'll go through all these things in very much detail. This was just to explain you
Hmm.
the risk concept. So any doubt here?
No, from my side it's clear.
No, no,
Okay.
clear.
Okay. Okay, now comes the concept of defense in depth. You understood these things. Okay, I think so we are done with everything here. So, defense in depth. What is defense in depth? Defense in depth. I'll just come back. Okay, you wouldn't be able to see that. Wait, is my screen visible? Hello,
Yeah,
Hello.
Mohammed. Yeah.
it's visible, right? Okay. Okay. So,
Hmm. Yes.
uh, okay. So if you see here, this was the medieval castle I was talking about. So defense
Hmm.
in depth. What is defense in depth? Defense in depth is basically security at different layers. Okay, at different layers. So if you see limited entry points, guards check identity, high hard walls, moat, inner walls. This is your main critical, what do you say, critical asset, which is where your king is sitting. Okay, these are the watchtowers. So, for example, I managed to get into this limited entry point anyhow. I was able to go through the guards check identity also. And if I'm roaming in here, okay, I'm roaming in here suspiciously, then there are watchtowers, right? And everybody is being watched continuously, like what activity they are performing. Then there are inner walls. If I try to penetrate here, then the inner walls will stop me. Okay. And again, if I'm not able to get through here and I try to go through from another side, you see there is moat. So this moat is basically some kind of protection only, where you cannot get through. It must be some liquid, some sticky liquid or something like that. Not sure. And then there is a high hard walls, which is difficult to climb. Even if you pass these two hurdles, and if you are climbing the wall, definitely from watchtowers you are being seen that what you are doing. So you see, it's not just this particular entry, okay, security guard, security check, done. That's not defense. Defense in depth is till your critical assets. Till your critical asset, till your main part, you are defending it in layers. Okay, you are defending in that in layers. So any questions here?
No.
Okay. So now coming to another concept, which is Maitre attack model. Have you guys heard about this?
No.
No, this
This
is
is
brand
new.
new.
Okay. Okay. So I'll be sharing this link in chat, and you need to be very much proficient in this. At least understand. Okay. You don't need to by heart this. Okay, but there is no chat option.
Chat is there.
There.
Just
Yeah.
say hi here. Hmm.
Okay. This is the link. Okay. Now, what is this model? Every every attack has its its layers. Okay, its phases of attack. For example, if you want your target is to exfiltrate data from a database, okay, then ev- these are the tactics. Okay, these are the tactics: reconnaissance, resource development, initial access, execution, persistence, privilege escalation, defense evasion, and these are the techniques for that tactics. Okay, so there are 10 techniques you can follow for this tactics. Active scanning, if you see, scanning IP blocks, vulnerability scanning, word test scanning. So so what is this exactly? You don't need to focus on the techniques, you just need to focus on the tactics as of now. Okay. So for example, let's take come to our example only. So you need to attack this particular application, which is here. Okay, which is sitting here, this database. And your what is your end goal? Your end goal is to take out your end goal is to take out the data from the database to your particular location. Okay, whatever location you have configured, maybe some cloud storage or your personal laptop. You need to just create a covert channel from here to your destination. So how will it work? Okay, if you see, you need to maybe let's take a scenario where this backend one and backend two, none of them are exposed to internet. Okay, none of them are exposed to internet. Just cut this out. Just cut this out. Okay, and when they want to communicate with each other, When they want to communicate with each other, what they do, that's the internal cluster routing. Okay, traffic goes from this back front end to here, or maybe from here to here. Okay, this is the flow as of now. Okay, and the only entry point here is your front end. That too via firewall, load balancer, ingress, front end. That is the flow. Okay, so what will happen is that when you try to hack this particular database based on SQL injection, right? So what you need to do, you will issue commands which will go from here to here to here to here, and then the script. Okay, but what your goal is not just to issue a command in database and read the output, maybe to get the tables and columns, everything. That is not your end goal. Okay, your end goal is something which says is you have a location on internet where you need to transfer everything from here to this particular location. Okay, this is your end goal. So when you talk about this, there are different phases of an attack. So reconnaissance, what is reconnaissance? Reconnaissance is something where you learn about your targets. Okay, like there are two things, passive and active. You have been given that, okay, you need to attack Amazon. Okay, so you what you will do is you will search every possible way on internet to gather information about Amazon.com. Okay, or about that particular company. So when I talk about every possible information, it also includes the email addresses of particular employees which are exposed or which are there on the internet. There are a lot of techniques. So when you learn the VAPT, you in the VAPT, it's like the first step for any penetration engagement is reconnaissance. So there are two things, active and passive. So passive is something where you don't have any idea what is my target. I just know the company name. That's it. And active is something where you have given a URL. In our case, you have a URL. Okay. Okay. This is the website abcd.com which you need to attack. Okay. So this is the first phase where you know your attack, know your target. Sorry. Then there are resource development where which tools I will use. Okay. What is the requirement? X, Y, Z. This is just setting up your infrastructure for the attack. Then comes the initial access. Okay, initial access. What is initial access? Maybe you compromise this particular front end. Okay, this particular front end is compromised. You are able to execute remote commands sitting from outside to this particular front end. Okay, this is compromised. So I would say, okay, so when I talk about initial access, maybe there is someone sitting here and he has compromised your front end, and you can issue basic. If it's a Linux pod, you can issue basic commands like who am I, or if config. These commands you can enter and you will get a output. So what we call this as reverse shell. So basically, what you have done, you have compromised this front end pod. You have initial access into the application. Okay, and how you can see the techniques now. If you see the techniques, there is phishing, there is valid accounts where you have valid account credentials, and there is content injection, hardware additions. You can add a what do you say, a pen drive or something like that. And what in our case, what it is, exploit public facing application. So you see here, exploit public facing application, initial access. So this is something, when you talk about public facing application, this is a scenario for each and everyone on internet, every application on internet which is exposed. Also, anyone can get compromised, any application get compromised which is public facing. That's what we are doing. By some means you have compromised this application, and you say that as a initial access. Okay, now moving ahead, there is execution. maybe on this particular front end pod, you need to execute some script. What, you don't have any idea, right? Just think that you are blind. You have just landed on this front end and you don't know anything about the architecture, about the flow. And now you need to understand, and you know that they are using some database, definitely, because every application uses database. You need to get to the database from this particular application. So you are now having a shell of this application, and now you want to issue commands like basic networking commands, ns lookup, check the dns settings, and network discovery commands. You can run a script to check every particular pods or services running in your subnet. For example, now you are in a private IP, right? You if you enter if config, you will get a private IP address in your shell, which means, okay, this is the pod which is running on a private IP. Now you can scan that particular subnet. So there are tools like nmap, which is used to scan your network discovery. So such kind of scripts you need to execute. So that is the execution part of the attack. And this attack can be stopped where you are just giving your particular application or front end just the required access to run just the required scripts. That's it, nothing apart from that. So if you will try to execute even a curl command, even a simple curl or ping command, it will say not found. It will say not found. Why not found? Because it's a base image, right? It's a slim Docker image. Only the required things are running here. Then what you need to do, you need to install those particular services, particular packages, for example, ping, curl. And if you are not running as a root, you cannot install those commands. Okay, or those packages. You cannot run that command. So it would be something like you are stuck here only. You are stuck here only. You cannot do anything from there. Why? Because your front end pod is not running as a root, and it can never run as a root. You cannot elevate the privileges also. So what I said, defense in depth. Okay. So when I say defense in depth, you see, if somebody the first layer of defense. Okay. Now, okay, any doubts still here, like whatever initial access I explained, till this command execution and this initial access. Any doubt?
No.
No.
Okay. So I will move forward. So if you see here, if you see in the defense in depth concept, what happened is you in the browser, there were few security mechanisms are there, which are specific to client side attacks like cross site scripting or CORS. Okay. Or some content sniffing. Such kind of attacks are there which happens at the browser. So there are few security mechanisms like security headers and some course headers which should be there to protect you. So this was the first part. Okay, your SQL injection, this particular defense. Okay, this black sign which you are saying, these are the line of defenses. This particular defense had nothing to do. It couldn't stop this particular breach. There was a web application firewall. Okay, so web application firewall can detect and stop malicious packets. So when you were passing the malicious packets to get hold of this particular service, okay, to get the initial access while you were passing those packets, this WAF was good for nothing. So it was a WAF bypass. So attacker was able to bypass your WAF. So WAF is a good layer of protection, definitely, but it should be configured in a way where it shouldn't allow any attacker to get into. So for that, you need to get more restrictive. There are rules in WAF, and if you configure your WAF in a more restrictive way, then the legit traffic of the application will also get blocked. So this is a very big issue with the WAF. WAF is like a separate team sits and configures and manages the WAF. It's a very critical asset, very critical line of defense for an application. So when I talk about defense in depth, you see all these things: 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything are layer of defense. Layer of defense, just the way we saw here. Layers of defense. These are the layers of defense for your application. Okay, for your application, these are the layer of defense. So when when this particular guy got compromised here, the front end got compromised, and he was able to bypass all these some security configurations of load balancers also. Ingress also, you are able some IP restrictions or something you configured on ingress also. Everything he was able to bypass, and he was able to get to the front end pod. Okay, he was able to get here. He was here, but okay, but he was not able to move forward from here. Why he was not able to move forward? Because this particular pod was very much restricted. It was running as a normal base image, slim base image with limited functionalities, which was required for him to work as per the business logic. So if you can imagine, even if a ping and curl command was also not working, then it was a very much slimmed and trimmed image. Okay, that was one thing. Second thing was that you configured it as a non-root, and a non-root pod with no privilege escalation functionality. Even if you try to elevate the privilege, if I am the admin, infrastructure admin, and I try to get into the pod and I say, okay, I need to test few things from this console of this pod, but what I need is I need to elevate the privilege. Then also you won't be able to elevate the privilege. You need to change the Docker file, the deployment file, redeploy this pod. Then only you would be able to elevate the privilege. So what happened here? By elevating the by adding a line of defense here, you stop the attack. Where you stop the attack? You stop the attack at this execution layer. Okay, you stop the attack at this execution layer. So that is what defense center. One misses, another catches. Okay, if all of them misses, some or the other catches. That is the concept of defense center. Okay, so any questions here?
No
No,
questions.
it's clear so far.
Okay, so now let's move forward to with the same concept. I'll move. I just want you to demonstrate every phase of attack actually. So now take a scenario where your front end was badly configured. Okay, badly configured, and you were able to issue the commands, and you understood. Okay, there are multiple pods running under this particular subnet. There are 2 3 pods. I got some DNS settings also. You got lot of things about your infrastructure, your cloud. You got it from this particular pod. So what you would do is, next thing is, okay, next thing is, I'm in. Okay, I have a reverse shell. I have a reverse shell. But what if this pod restarts? Okay, what if this cluster stops? Maybe there are scenarios where this is a development cluster or a UAT or a pre-prod cluster, and these clusters are usually stopped during non-working hours, only production runs. What if this cluster stops? Then what you need to do again, all the hard work which you did, which the attacker did to bypass all this security mechanism and get hold of this pod, that would be nullified. Again, he need to do all this hard work. So there comes a concept of persistence. So what persistence is? That whenever this particular pod boots up, I will be having a reverse shell. I can issue commands to this pod. So for that, he needs to run some script, some backdoor. Backdoor you have heard about, right?
I've heard the term, but not sure exactly what it is. So it's some sort of a loophole in the architecture, right?
Backdoor is something where you deploy a backdoor. For example, you run a you what you would do here is, you would configure a cron job. You would configure a cron job to run on this particular container, and what that cron job will do, that cron job will run every 2 hours, every 1 hour, whatever time you have given, and that cron job will open a shell connection to this attacker. Okay, that's what a backdoor is. Like, backdoor are intentionally also configured by developers to get into their application, and sometimes this backdoor can be used by the attacker to compromise that particular application.